Okay, in this video here, this lesson, we're going to go over just the polynomial end behavior. We're talking about end behavior. We're talking about the ends of the graph, right? Um, of the polynomial when we graph them. When we look at functions numerically, as we're talking about, we plug in bigger and bigger values and smaller values for x, our input, what our y value does. Now, any graph of a polynomial graphs are always what we say. They're smooth graphically, all right, and we say they're continuous. Okay, so we have polynomials. When we graph them, they're going to look like this. They're going to be nice and rounded. Okay, you might have different amounts of hills and valleys. Okay, but they're going to be nice and smooth. And continuous means that if you put your pencil down and you traced along it, you would never have to pick it up. Okay, clearly this would not be smooth. Okay, so that's not a polynomial. This would not be a polynomial. Okay, it's nice and smooth. It's rounded, but there's a jump here, so that's not continuous. There's a little break in the graph. Okay, not continuous. So any polynomial function, when you graph it, will be nice and smooth, rounded, and continuous. Now, in terms of end behavior, so this is what we mean by end behavior, the ends of the graph, out here, okay, out here and out here. The ends, not in here. This isn't what we're in here. No, that's not what we're talking about for end behavior. There's a lot going on there. Let's erase that a little bit. Okay, so end behavior, we're talking about the ends of the graph. So this is what we have. Let's kind of formalize this a little bit for you, kind of make it as simple as we can here. This is what we got going on. So any polynomial function, first graphically, this is four things that can happen. Either both ends turn up, both ends turn down, one side goes up. Let's go in reverse. What I have. One side goes up, the other side goes down, or other side goes up, this side goes down. So that's what the ends of the graph could do. Okay, so we have four scenarios. You could break it up into four little scenarios. Now, this is what happens. It's based off of two things. It's based off of the degree of the polynomial. Okay, and remember the degree is the highest power, and the leading coefficient, right, which is the number that goes with that. Now, right here, when do I know that both sides go up or both sides go down? All right, so right here, all right, we can make a little table, right? That in here, the degree is going to be even. In both of these scenarios, the degree is even. So if the degree is even, then both sides either go up or both sides go down. Think even, the same, equal. Okay? Now, leading coefficient. What about the leading coefficient? If the leading coefficient in this case, what happens is positive, okay, positive, then the graph on the ends is going to look like this. Okay, and what you can always think of is this side, the right side of the graph for all these. When the positive, the right side's going to go positive, and since it's even, so is the left side. Over down here, even tells me both sides go down, right, or up. But in this case, when the leading coefficient is negative, then that means both sides are going to go down. Again, if we look at the right side of the graph, negative, it's going down towards a negative y value. Now we get down to these two. Now notice that one side goes up, one side goes down. They kind of do opposite things. So in this case, the way to kind of remember that is odd, opposite, O, right? That both sides are going to do opposite things. One side's going to go up, one side's going to go down. So in both of these scenarios, the degree is going to be odd. So if you're an odd degree, one side's going up, one side's going down. Well, how do I know if this side's going up and this side's going down, and conversely the other side? Is the leading coefficient? Well, in this case, positive. How do I know it's positive? The right side is going positive direction, going up. Okay. And then over here, this would be negative. So what you want to have in your mind when you're doing this is if the degree's even, both sides are doing the same thing. If the degree's odd, both sides are doing opposite things. And how do you know what they're doing? Well, The leading coefficient, positive. This always corresponds to the right side. Positive, going up here to the positive. Negative, going down here to the negative. Positive, going up here to the positive. Negative, going down here to the negative. And then once you know that, combine those two. Well, if the right side's positive and this is even, it means the left side has to be going to the positive. Even, negative. Oh, that means the right side's negative. The left side must be the same because it's even, so that goes to a negative. Here, odd. Sides are opposite. Positive, right side's positive. Opposite, left side must be negative. And here, if the right side's negative, then the left side must be positive. So that's just a little graphical interpretation. Now, how are we going to formalize and write this result? Okay, so how do we actually write the answer, our conclusion? Right? How are we going to formalize our answer in terms of writing this? All right. Well, here, what we're going to write is as x, this little arrow, right, is read approaches. Okay, and then we write plus, minus, infinity. Right. So what this means is, as I go this direction, which would be going to positive infinity for x, or if I go in this direction, which would be going to negative infinity for x, right? So as my x values go bigger, or my x values go smaller, what's my y value doing? Then we just put a little comma and we write f of x, which is my y value, is approaching, that's read approaching, positive infinity. So when you have an even degree, positive leading coefficient, that's how you write your answer. Okay. And this is, again, is read as x approaches plus or minus infinity, f of x approaches infinity. Down here, we write as, in this case, x approaches plus minus infinity. That means if I go in either direction, you either go to the right or go to the left. F of x, in this case, approaches negative infinity. And there's that side. Now we get down to the odd ones. Well, the odd ones are a little different because, well, we're not doing the same thing as we go in both directions. As we move to the right, my y is doing one thing. As I move to the left, my y is doing another. So we separate that into two statements. We say, as x is going to infinity, which would mean moving to the right, right? As here's going to the right, x is approaching infinity, going in that direction. What's my y doing? As x goes to infinity, f of x goes to infinity. And then as x goes to negative infinity, what's f of x doing? Well, if it's odd, that means I got to be doing the opposite thing, going to negative infinity. So as I go in this direction, as x goes that way, my y goes that way to negative infinity. That's my f of x. And then lastly, this one, right? As x goes to infinity, as x goes to negative infinity, right? We have what? F of x goes to, in this case, as I move to the right, I'm going down, so that's going to be negative infinity here. And over here, f of x is going to go to positive infinity. Okay, so that's how you write all those four different scenarios. Because both sides and the top two do the same thing, I can write it in one statement because it doesn't matter. When I go in both left and the right for x, bigger and bigger values for x and smaller for x, my y does the same thing. Here, I got to separate into two different statements. Okay, we could separate into two different statements here, but we don't need to. Okay. So now, how's this look in practice? What do we do? Well, here we go. We'll say determine the end behavior for each function. Determine the end behavior for each function. Okay, so let's go with this this first function here, and let's make this one f of x equals negative 2 x to the fourth plus 3x squared plus x plus 5. So in order to do this, you're going to need two things. You're going to need the degree to start. What's the degree? And what is the leading coefficient? Okay. And in particular, the degree, well, what's the degree? It's the highest power. We look up here, and we see the highest power is 4. And in particular, it's 4, but also in this context, what we want to know is that, well, 4 is even. And then what about the leading coefficient? Leading coefficient right there, -2. And in particular, the -2 is negative. So now one thing that could help is you just think about what this means. Even, both sides do the same thing. Negative, that tells me the right side is going to go down, and the other end of the left side is going to go down. So a quick little graph to go, oh, okay, that means now what? How do we write? And this is what my answer is. As x goes to what? Positive direction, negative direction. So plus, minus, infinity. What does my y do? Where's y going? Right? If I don't know what this graph looks like, but if I put this on a coordinate plane somewhere, the y values, right? Here's my y-axis, here's my x-axis. I'm going towards negative y. This is my y. Y is approaching negative infinity. Done. This is how the answer looks in the end. Okay. And as I stated, you can separate this into two statements. And quite frankly, you could, if you want to, you could do this. You could go ahead and set up a template because every one of these, you could do this. As x approaches infinity, f of x approaches, leave a blank. As x approaches negative infinity, f of x approaches blank. And now just fill in the blanks, right? What goes here, right? This you could always do it this way because this is going to be true every time, no matter what, even, odd, positive, negative. And now we could sit in here. Oh, well, this is negative infinity and this is negative infinity. All right, so these two are the same thing. It's just because both sides do the same thing, we can wrap up these two statements into one. Okay. Let's do another one of those. So go over here. We'll go to second one. So here's g of x. And this one's going to be 3x squared minus 3x to the 5th plus x plus 5. Okay. Determine the end behavior. So again, here we go. We need the degree. And I need the leading coefficient. And we could do this. We can go over here, and before we start, we could say as x approaches infinity, f of x approaches. As x approaches negative infinity, f of x approaches. And then fill in the blanks. Okay. X approaches infinity, this is moving to the right. X approaching negative infinity, this is moving to the left. Now we can go over here and say, oh, what's the degree? Don't look here and go, oh, 2. No, highest power. Right? It's not in standard form, but we don't need to. We just look here. Oh, there it is. There's the highest power, 5. So this is a degree 5. And in particular, that means it's odd. Now, what about the leading coefficient? Here's x to the 5th. What number's in front of that? Make sure you take the sign. -3. -3 leading coefficient. What about this? This is negative. And now maybe do a little quick sketch. Odd, but one side's going up, one side's going down, right? Negative, this is the right side. So if I think of two sides, the right side's going to be going down, the left side's going to be going up. And now we put in here, well, going to the right, where am I going? I'm going down this way towards negative infinity. Right down here is negative infinity for y. And then as I go to the left, what's my y doing? Going up towards positive infinity. Done. That's it. Okay. So that's all there is for determining end behavior. Okay, what this is saying is I plugged in bigger and bigger and bigger values for x. If I kept on plugging bigger and bigger values and bigger and bigger values and bigger and bigger values, where is this whole value going to go? Right? This is your y. Well, as x goes bigger and bigger towards positive infinity, my y's are going to get smaller and smaller towards negative infinity. Going the other direction, if I plug in negative values for x, right, and they keep getting smaller and smaller, right here, then my y is going to get bigger and bigger. Right? That's what it says. And graphically, it would mean that one side's going to turn down and keep going down. One side's going to turn up and keep going up. All right. So there's the two examples. Right. And the only other thing would be what happens if you have a positive or negative, and even on you have one of these four scenarios. So watch this over. You're gonna work on these problems. Don't overcomplicate it. Make sure you pay attention to notation. If you have any questions on anything here, you let me know. We'll go over it in more detail. All right, and by all means, pause, rewind, watch again. Okay. And then, like I said, let me know if there's anything you want to go over, if you don't understand something. And if it's something in this video, let me know what time um, in the video you were a little confused. And in particular, what in the video at that moment in time you were confused on. That way, ahead of time, before we meet, we can go over it. All right.